Okay, let's explore a little bit more about programming. Now we got our script here, so I'm going to save that. And save it here, and this will be, I'll call it chapter 2. This is, we're going to explore some topics with chapter 2. And I could have a variable where I say a is equal to 1. Now, what I've done here is, this is a actual variable. A variable stores a value, kind of like a memory cell in a brain. You think of a date that you can remember. Well, that date's being stored in a memory location. Well, variable is a memory location for our program. And then I could do a print, and has beginning parentheses, closing parentheses, and I put the variable name inside. Now if I run this, here's the run file, this option right here, or you could do F5. Then you see it prints a value 1. Now, I can do a equals a plus 3. Now this equals here is not the same as how an equals would work in algebra. This is an assignment, such that when I run this, you see it gives me the answer of 4. Well, how does it do that? Well, let's talk about that. Okay, you've created a memory location in your program, and you referred to that as A. Okay. This first line here, A is equal to 1. What that does is it puts the value 1 in this memory location. Now this next line of code right here, A is equal to A plus 3. How you can think of this is it works on the right hand side first. So this A here goes and retrieves the value from that memory location. So it'll go and get to 1. And then it'll add 3 to it, which gives us 4. And then this equals right here means that it takes that 4 and assigns it or places it back into this memory location. So it wipes out this value and it puts 4 in here. So when we print A, then we're printing the value at that memory location. Now you can have all kinds of different code here. Let's say I'm trying to figure out my sales tax. And I'm going to do a pound sales tax calculation. The pound is a comment. That means that the Python program will ignore that. That's merely for you to document what's going on. And let's say sales is equal to $1,000. Tax rate is equal to 4%. So then, if I want to figure out what the tax is going to be, I can say tax is equal to sales times tax rate. And then I could print tax. So if I run this, of course we get our 4 from before, and then $40, which is 1,000 times 0.04. Now how this handles the memory. Ignoring the top part, comes down here and it creates a memory location for sales. So sets this aside and says this is now where we're going to store sales. This assignment here assigns 1,000 to sales, so it stores that in that memory location. Then it comes down here, runs across this new variable called tax rate. It sets aside that memory location. And here it's putting in 0.04. Now this down here is performing this calculation on the right side first. So it's calculating 1,000 times 0.04, which is $40, and then it's putting this into this memory location. So it's placing the $40 in there. Now specifically, it printed off 40.0. That right there. And then this print, it goes and retrieves the value from that memory location and prints the value to the screen. Now the benefit of having separate variables here versus just putting 1,000 here and 0.04 here is that later on, as we start programming more, we can ask the user of the program what was sales. Was it 500? Was it 700? Was it 1,000? We can ask them what the tax rate is. And then this line here will then calculate that. So the eventual idea is we will not be hard coding it like you see right here. Now 1,000. If you use this as an integer, you can think of it as not having any decimal places. Here, if you use this as a double, some books refer to that as a float, though double is a little bit more accurate. Means it has decimal places. When you take an integer and you multiply it times a double, then what you get is a double. So that's why it's 40.0 instead of 40. If I had a different program, demonstration of integers, let's say S is equal to 1,000, T is equal to 40, and total is equal to S times T, and then we'll print total. Now if I run that, you see this does not have any decimals here. This is stored as an integer. Now that becomes important later on because sometimes it gives you maybe results you're not expecting. I don't know what this will actually do, but let's do S divided by T and run it. See here, S was an integer, T is an integer, and when I did the division, it assumed I wanted a double. I wanted decimal places. If I wanted to do integer division, then 1 divided by 3 should have gave me 0. So it's kind of strange. You know, integer division is where you do the old style here. 3 doesn't go into 0, or 3 doesn't go into 1, so that's 0. 0 times 3 is 0. You subtract that, and our answer is 0. But we do have a remainder also. Well, this assumed we wanted it into float. So there's ways around that, but that's something to keep in mind. If you get bizarre results, it could be that it's automatically assigning the data type. Now let's talk about data types since we're talking about variables. The book talks about this. Number with no decimals is considered an integer. If you have decimals, that's referred to as a double. Some books refer to as float. If you have quotes around it, this would be considered a string. Now there's other data types. Those are just 3 main ones we're going to work with here initially. So this demonstrated how to declare a variable just by using it and assigning a value to it. And also talked about, and we'll see more detail later on, how can you change a data type, how can you specify it to begin with. We also looked at the assignment operator, and then we also looked at comments and some of the different data types you may run across.